All right, so let's keep trying a couple more examples here. So again, if you subbed infinity in to any of these, you're going to find that you get infinity over infinity. So we can't have that. So we have to use the notion where we're going to be dividing by the highest power of the x in the denominator. So highest power in this case is x squared. So when we write it out, we take the limit as x approaches infinity, 2x over x squared, we don't need the coefficient with it, 5 over x squared, denominator, 3x squared over x squared, 1 over x squared. And we're going to simplify. So we have the limit as x approaches infinity, 2 over x, 5 over x squared, 3, 1 over x squared. And now we're going to go through each one as if we took the limit of each. So we have 2 over x, well that's 0. 5 over x squared, that's 0. 3 is 3, and 1 over x squared is 0. So we end up with 0 over 3, and anything with 0 in the numerator is going to give you 0 for a final answer. All right, with b, same idea. We're going to divide everything by x squared because that is the highest power. It's always the highest power of the denominator, not the numerator, but the denominator. And then once I go over this, you still have to show me process-wise in terms of how to do this, but there is going to be a shortcut. All right, so when we simplify, we get 2, 5 over x squared, 3, 1 over x squared. So when I say shortcut, that shortcut is going to apply to checking your work, not doing your work. So we have 2 stays 2, 5 over x squared is 0, 3 stays 3, and 1 over x squared is 0. So we end up with 2/3 for a final answer for that one. Last one. In this case, we're dividing still by x squared, so notice the denominator hasn't changed in any of these cases. It was only the numerator. We're going to simplify. So we get 2x, 5 over x squared, 3, and we get 1 over x squared. So now when we have it like this, we know this is 0. So if I get rid of this guy, we know this is 0. So I'm left with now the limit as x approaches infinity of 2x over 3. So at this point, think direct substitution. Take the infinity, sub it in. 2 times infinity is infinity. Infinity divided by 3 still gives you infinity. Okay? If that was a negative infinity, then it would be negative infinity, but it's positive. So we went over 3 examples here. Okay? In Algebra 2, I believe, definitely Algebra 2, but possibly pre-calc, you went over ways of determining horizontal asymptotes. So there were 3 rules for that. Here's your 3 rules right here. So if the degree of the numerator is less than the degree of the denominator, your horizontal asymptote is equal to 0. So if we look at example A above, the degree of the numerator is 1, the degree of the denominator is 2. Well, that means that the numerator is less than the denominator, and we got a limit that was equal to 0, and the horizontal asymptote should be 0. So they match up. For the second one, if the degree of the top and the bottom are the same, then we should have a horizontal asymptote equal to the leading coefficient of the numerator over the leading coefficient of the denominator. So if we look at B, they're both x squareds, top and bottom. So our answer should be y equals 2 over 3, which if you check, that is our answer for limits. And for the third type, if the degree of the top or the numerator is bigger than the denominator, then there is no horizontal asymptote. So given that we're talking about limits, you can't write no horizontal asymptotes or slant asymptote, so your option is either going to be positive or negative infinity. Okay, so it's either positive infinity or it's going to be negative infinity depending on the question. All right, but now again, this is a way to check. And I'm going to just write down here, you still must show all steps. Show all steps like I did above. the nice part is, for many of these questions, you can just look at it and you already know what the answer is. So after doing all of the work, then just make sure that you double check that they do actually match up. But do not use this as the means of how you're determining it, because I will not be giving you any